Myself, Srikanth, Assistant Professor of EEE Department. In this lecture, I am going to present the topic from Elements of Electrical and Electronics Engineering. So, in the Elements of Electrical and Electronics Engineering, the course objectives are: the first course objective is the network reduction techniques such as source transformation, mesh analysis, nodal analysis, and network theorems to solve different networks. The next one is the basic concepts of AC circuits for optimization of household and industrial circuitry. The next is the construction and operation of electrical machines. And the last course objective is operational characteristics of semiconductor devices with their applications. And these are the course outcomes. After completion of this course, the students are going to able to make use of basic electrical laws for solving DC and AC circuits. And the second course outcome is apply network theorems for analysis of simple electrical circuits. The third course outcome is demonstrate the fundamentals of electromagnetism for the application of DC machines. The fourth course outcome is students are able to understand the principles of electromagnetic induction for the operation of AC machines. And fifth course outcome is utilize the characteristics of semiconductor devices for the application of rectifiers and regulators. And the sixth course outcome is interpret the transistor configuration for optimization of operating point. These are the course outcomes which the students are going to achieve after the successful completion of this particular course. And now we are going to enter into our module 1. The module 1 name is Introduction to Electrical Circuits. In this, basically the circuits concept, Ohm's law, Kirchhoff's laws, the equivalent resistance of networks, source transformation, star to delta transformation, mesh and nodal analysis, and single phase AC circuits, representation of alternating quantities, RMS, average, form and peak factor, phasor notation, RLC series circuits, the concept of impedance, admittance, real power, reactive power, apparent power, and power factor. These are the topics which we are going to discuss in the module 1. So immediately once if we are discussing about electricity, immediately the word which we are going to get into our mind is voltage. What is voltage? What is voltage? Voltage is nothing but it is also known as electromotive force, where voltage or EMF, electromotive force, is defined as the potential difference between 2 points in an electric field is called voltage. What is potential? Potential is the energy required to bring a unit positive charge from infinity to that particular point in an electric field is called potential. That is, voltage is going to be defined as the potential difference between 2 points in an electric field. So here the voltage can be denoted represented as voltage is equals to potential difference, where potential energy is nothing but energy required to bring a unit positive charge. We need what is the amount of energy required to bring a unit positive charge from infinity to that particular point in an electric field is called potential energy. So we can write potential energy as energy per unit charge. Energy per charge. Potential energy can be written as energy per charge, that is equals to W by Q. This is potential energy. What is voltage? We have defined voltage is nothing but potential difference between 2 points in an electric field, where potential difference is equals to, we can take it as dW by dQ, that is change in energy by change in charge, that is equals to, the units will be, energy units are joules and charge units are coulombs. So the voltage units will be joules per coulombs in terms of joules, or we can take it as volts. We can write it as volts. Joules per coulombs can be written as volts. This is the potential difference between 2 points in an electric field. And the voltage source can be represented. Voltage source can be represented with a battery symbol, that is two straight lines, two parallel lines. One is with big length and another one is with short length, and these two indicates that big length line indicates that positive of the voltage and short length line indicates that the negative voltage. And this is one way of representing the voltage, and another way of representing the voltage is a circle with plus and minus. This is another way of representing the voltage, and these two are the examples for the voltage representation in DC circuits. In DC circuits, where DC is nothing but direct current circuit. Direct current circuits. Whereas for AC circuits, alternating current circuits, it is the same voltage, a circle with plus and minus with a alternating quantity, that is a sign function which is going to draw in between the positive and negative. That is nothing but a voltage in AC circuits. Here, how will be the voltage will be represented with the water tanks. When two water tanks with same water level, there won't be any change from there won't be any flow from one water tank to another water tank. Voltage, when there is a difference in the water levels in two water tanks, the water will flow from high water level tank to lower water level tank. So here the lower water level tank is going to receive the water from higher level water tank. In the same way, the voltage always starts flowing from higher potential to the lower potential of the battery. That is, always charges will move from higher potential of the battery to lower potential of the battery. This is the way how the voltage is going to flow, how the charges are going to flow from higher potential to lower potential, from higher potential to lower potential. And after the voltage, the next basic definition, basic word which we are going to get into our mind is current. The current is nothing but rate of flow of charge carriers. Rate of flow of charge carriers or charges. Charges may be electron, proton, neutron. So the flow of any charges can be called as current. In simple word, current is the rate at which the electric charge flows in a circuit at a particular point is called current. That is, the current can be represented as I is equals to rate of flow of charge carriers or charges. Rate of flow is nothing but dq by dt. Rate of flow is nothing but dq by dt. So the units will be coulombs per second. Coulombs per second or amperes. Coulombs per second or amperes are the units. And the current source indication will be, a current source can be represented in DC circuits, a circle with arrow mark, that is nothing but the current source in DC circuits. And in AC circuits, circle with arrow mark, along with the arrow mark there is a alternating symbol, a circle with a current source and a alternating symbol. This is for AC circuits. This is for AC circuits. How we are going to represent a current source in the AC circuits. And these are the voltage and current definitions. And now we will go with some other definitions corresponding to the circuits, that is energy. Energy is nothing but capacity to do the work. Energy is nothing but capacity to do the work. For any work, what is the capacity for completing that work is called energy. And energy units are in joules. Energy units are in joules. So here how the current flow, conventional current flow and electrons flow are represented. That is current flow from positive to negative, whereas electrons flow is in the reverse direction. Now we will go with the power. Power is nothing but power and energy are interrelated. So power is nothing but energy per unit time. That is how much amount of work is done in a particular time. In a particular time is called power. The rate at which work is done is called power. So the power units are energy per unit. Power P is equals to energy W by T, that is equals to, the units for power is joules per second or watts. The joules per second or watts. The power is usually measured in watts or horsepower, and here the path for conducting electrical current such as a component in an electrical circuit, power is equals to VI. And here we can write this power equation, that is equals to VI, from our basic definitions of voltage and current. Here The basic definitions are power is equals to W by Q into Q by T. Energy per unit charge. I am writing W by T into in a different fashion where we are going to get voltage equation and current equation. That is equals to W by I am dividing and multiplying the equation with Q. W by Q into Q by T. So W by Q, energy per unit charge, is nothing but voltage. Energy per unit charge is nothing but voltage, that is equals to V, and charge per unit time. Charge per unit time is called current, that is V into I, that is equals to VI watts. Now let us go with the classification of elements. Here the network elements are classified into 6 major categories. In that, first one is active elements, passive elements, linear and nonlinear elements, unilateral and bilateral elements, time variant and time invariant elements, lumped and distributed elements. Lumped and distributed elements. In this, first let us go with active and passive elements. In this, active elements, the active elements are classified into independent source, dependent source. In the independent source, again, these are classified into ideal source and practical source. And in the ideal and practical sources, again we are having voltage source and current source. And in the practical also we are going to have voltage and current source. And in dependent sources, we are having 4 different classifications: voltage dependent voltage source, current dependent voltage dependent current source, current dependent current source. And the passive elements are classified into 3 types: resistor, inductor, and capacitor. In this session, we are going to discuss the what are the differences between active elements and what is the different classification in independent and dependent sources. And next, we'll discuss the passive elements. First, we'll go with the active elements. In this, first we'll go with the active elements. In the active elements, first we are having independent sources. In the independent sources, first we are going with the voltage source. In the voltage source, again there is a classification between ideal voltage source and practical voltage source. In the ideal voltage source, the voltage, that is, which is going to have a voltage where Vs magnitude, where VAB value will be at any time or any change in current, the VAB value will be same as Vs. That is nothing but at any instant of time, the voltage will not vary, or there is no voltage drop in the circuit. Then that is called ideal voltage source. And here you can see the characteristics. Here this is the characteristic which is not changing at any time. At any time, this value is not changing. That is a constant value. Here the independent source is nothing but the source value does not depend on any other parameter in the circuit. The source value itself from the source magnitude only. Okay, here the in that ideal source is nothing but which is going to provide the ideal value, that is the exact whatever the voltage is there, there is no voltage drop in any conditions. Okay, that is the ideal source. Whereas when we go with the practical source, there is a resistance or in series with the voltage. There is a resistance in series with the voltage, where when there is a resistance in series with the voltage, here there is a resistance and some current will flow through it. When some current flow through it, according to Ohm's law, V is equals to IR. V is equals to IR. There will be some voltage drop in the resistance. There will be some voltage drop in the resistance where VAB is equals to Vs minus IR. Vs minus IR. Here when I increases, when I value increases, VAB value will decrease. VAB value will decrease. So here you can see clearly in the characteristics, voltage versus I or time, current versus voltage versus current. If we draw here, actually this is for ideal. When we are taking the practical, there will be some drop. This drop is in the series resistance. Always when we consider when we take any voltage source that will have a small amount of resistance, that will reduce some voltage, a small voltage only, because of the resistance of conductive material or other elements which are connected to the source will have some resistance. Because of that resistance, a small voltage drop will be there in all the practical sources. But when we are discussing the concept of circuits, we are going to discuss with the ideal sources only. And the next independent source is the current source. The current source is also just like it is independent of the circuit. There is no dependency in this current source, in the independent current source. And in this also again, these are classified into two types, ideal and practical current source. Whereas ideal current source will be same like how the voltage is there. There is no any deviation in the current. There is no path for the current to flow. So the current will be constant whatever the change in voltage or time. The current source is of a constant magnitude, which is of constant, even though there is any change in voltage or time, there won't be any change in the current magnitude. There won't be any change in the current magnitude. This is the ideal current source. When we take the practical current source, a current source will be in parallel with the resistance. The current source will be in parallel with the current source. When there is a parallel resistance, some current will be flowing through it. Some current will be flowing through it. Let us consider that current as IR current. This current will be flowing through the resistance when some current is deviating. This is the IR current, where the output current will be IAB is equals to IS minus IR, where IS minus IR will be equals to voltage across the resistance by resistance. When voltage increases, current will decrease. When voltage increases, current will decrease. Here When voltage is increasing, current will decrease. This is the reduction in the current. A small amount of current only. This generally we are going to neglect when we are discussing the circuit concept. Okay, but when we are going with the practical connections, that drop will be there in the both current and voltage sources. Now we'll go with the next classification, dependent source. In the dependent source, here the output of the dependent voltage source is not fixed. It depends on either voltage or current flowing through, either voltage or current flowing through the any other part of the circuit. Any other part of the circuit is called dependent source. That means dependent source magnitude will be depending on the voltage or current of any other part of the circuit. And these dependent sources are further categorized as voltage controlled voltage source, voltage controlled current source, current controlled voltage source, current controlled current source. The voltage controlled voltage source. Here, the voltage controlled voltage source is the voltage of the dependent source is depends on VCD. That is nothing but this is the VAB. VCD is nothing but voltage across the resistance. That means here VCD into some constant K. VAB is equals to VCD into K. That is, the dependent source voltage is depending on the voltage across a particular resistance. Voltage across a particular resistance. That is, voltage across that particular resistance is controlling the magnitude of the source voltage. That's why this is called voltage controlled voltage source. And the next dependent source is voltage controlled current source. And here the current source always indicates with arrow mark, and dependent source is nothing but which is going to represent in the diamond shape, where current source current magnitude IAB is proportional to ICD, that is current flowing through, sorry, not the current source, this is voltage controlled current source. Here VCD, IAB is proportional to VCD. IAB is proportional to VCD, so IAB is equals to some constant into VCD. Some constant into VCD. Here, the current of a dependent source is proportional to the VCD. So, here the voltage of a particular resistance is controlling the current source. That's why it is called voltage controlled current source. And the next one is current controlled voltage source. Here the source is of voltage VAB and the controlling parameter it is the current controlled voltage source. VAB is proportional to ICD. VAB is proportional to ICD. So VAB is equals to R into ICD. That is, voltage across this particular source is controlled by the current flowing through a particular resistance R. That is nothing but current controlled voltage source. And the next one is current controlled current source. That is, here current is proportional to current flowing through the other element in the circuit, where IAB is proportional to ICD, where IAB can be written as beta into ICD. Beta into ICD. That is, the magnitude of current source is controlling by the current magnitude which is flowing through the resistance which is connected in the given circuit. That's why this source is called current controlled current source. This is about the dependent and independent voltage sources. That is our first classification in the elements. That is active elements. Active elements are nothing but the elements which are going to deliver the energy to the circuit are called active elements. The next elements are the passive elements: resistor, inductor and capacitor. Now we'll go with the resistor. Now first passive element is the resistance. So before discussing the resistance, we need to discuss the Ohm's law. Ohm's law states that at constant temperature, Ohm's law states that at constant temperature, voltage across any conductive material is proportional to the current flowing through it. Voltage across any conductive material is proportional to the current flowing through it. That is, V is proportional to I, where V is equals to IR, where V is equals to IR, where R is the resistance of the conductor. So here V is proportional to I. From this, we are going to get R is equals to V by I. So here the resistance is going to, resistance value will increase when the current value decreases, or when the current increases. When the current value increases, resistance value decreases. So the property of a material to restrict the flow of electrons, the property of a material to restricts the flow of electrons is called resistance. R is equals to rho L by A, where rho is the resistivity of the conductive material and L is length of the conductor in meters, A is area of cross section in meters square. So here the resistance can be, this is the symbol of the resistor, this is the symbol of the resistor which is going to represented with R, and for any resistor we are going to give the sign convention. When the current enters into the resistance, whatever the current entering point for the resistor can be taken as positive and leaving part can be taken as negative for voltage across that particular resistance. Voltage across that particular resistance, where VR is equals to IR, I into R according to Ohm's law, where R is equals to VR by I. So the units will be volts per amperes or ohms. Volts per ampere or ohms. Yeah, inductor, capacitor we'll discuss in the next. In today's session, we have discussed the basic definitions and the classification of elements. In the classification of elements, only we have discussed the active elements and passive elements. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.